So I'm Ryan, and I'm kind of in the beginner track. I kind of had this, I asked my coworkers who were kind of getting new to Node and stuff like this about what I should talk about. And they were like, what happens when like I ask for stuff on the internet? Like what actually goes on? So kind of had this idea, like an anatomy of a web request. And so we're, as developers, the web is so fundamental to what we do, and a lot of times we take it for granted, like what goes on underneath when we're doing things on the web. So I just wanted to kind of explore that a little bit. I had a lot more stuff I wanted to cover, but I felt like I had to chop a few things off. So this might be talk one of who knows if I might book some talks in the future just to continue this. There's a few experimental things I'm going to do in this. Some object lesson stuff. Should be kind of fun. I've done that before in another talk. It seemed to go over well, so we'll see how it goes. Anyway, so let's start off. Sending messages is vital. Okay, this is kind of an important part of being a human, being part of a society. We have a thing in our history about Laura Secord, who she learned about a surprise attack from the Americans, and she walked over 20 miles, and she was escorted even further by some Mohawk warriors so she could tell the information to what was then the British, and that helped foil the attack. So there's a classic problem in networking called the two generals problem, where you're trying to send messages to each other, and you don't know if your message is going to get through. And these are kind of the things you have to tackle in networking, and it's super important for, the web right as it's built is all about sending messages, and hopefully the Americans don't have a surprise attack for us again. So the internet is engineered to send messages. That's why it's so successful. This is I think it was from 2 years ago. Someone kind of mapped out the breadth of the internet. And so let's kind of investigate how it works. So basically, this is a sketch of what happens to data as it goes along. So basically, does this have a laser?
It does, yeah.
Yeah, I can never see these because I'm red colorblind, but so this is user data. Your application wants to send a message. This is kind of where you kind of say, hey, this is the stuff I want to send. You pass it down, and what keeps happening as each layer as it goes down, the network stack has all these different layers, and they keep adding information to the front of it. And so this thing gets to the wire, which is like, it could be the Wi-Fi, or it could be Ethernet cables coming out of your computer, and all this data kind of gets sent out. And then as it goes along to all the other computers, it's, these things pop off and on as it's getting routed to different places. So that's kind of the high-level picture of what goes on. We'll kind of get into it. So I have what I'm calling the network game. So welcome everyone to the network game. I'll explain the rules. Each of you here are going to be a computer, okay? So just act like one. You're going to receive a networking card. I never give out cards, so this is like networking. Okay, when you receive your card, on one side there's going to be printed an IP. Okay, it's totally a fictional IP, but you're probably familiar with IPs on computers. They don't look anything like it. On the other side is you have what's called a MAC address. This is your unique computer ID. They're very different things. Okay. When I hand these out, one of these cards is going to have on the word server on it. Okay, don't tell anyone if you get it. Okay, it's a secret who you are. So the goal is for me to send data to that particular person. Okay. So what you'll do is when you get your card, kind of look at both sides, just check if you have server on the one side. You'll put it so your MAC address is in front of you, or you can hold it if you're in the back row so your neighbors can see it. I'm going to pass out envelopes, and you guys are going to have to route it around. You can only pass to your immediate neighbor. That's one of the rules, okay? You can't walk around, you can only pass to your neighbor. So if you're kind of in a corner that's maybe behind you and beside you. With one special rule, I'm going to pass out dots just because we have large gaps. Those dots will be super networking stations where you're kind of jumping to different bigger networks. So if you have a dot, you can pass to a dot with the same color in a different table group or cluster. When you pass it, so you're going to get an envelope, and you're going to look at their MAC address on the front of them. You'll write it, and you'll pass it to them. That person will receive it, and if the MAC address is matched, which it could, to strike it out, it's just a way to kind of keep track of where this thing went. Now, also on the envelope, I'm going to put the IP address of where it's trying to get to, and if it matches, you get to open the envelope. You're that lucky server person. Otherwise, if your IP doesn't match, you go to line 7, so you're going to pass the envelope to your immediate neighbor. So I'm going to help get people to help pass these out. So I've got a file.
I can pass them up too.
So yeah, so just, pardon? Yeah, I'll have pens, so don't worry. I'll pass it with the envelope. So start there. Make sure blue only gets to here. I'm going to pass this.
Move it over to there.
Yeah, here. Yeah. You guys just pass these cards to the end of this row. You guys get to pass these here.
Okay.
Why don't you guys pass it?
So when you're passing, you're writing the MAC address that you're passing.
Yeah.
Yeah.
Right there. Right there.
Okay, so I'm going to give you guys dots since you're pretty much neighbors. I'm going to give, how about you get a dot here, you get to pass it.
Okay.
Stick.
That's
You get a card.
So okay. Wow, teachers have to do this every day. It's very complicated.
I know, I'm just trying to make sure I understand all the rules.
I know I was too. But I'm not a computer.
No.
Okay, let's do it. I think those are everywhere. I don't know if this is working. I just made this. I invented a networking protocol, so this isn't really how. Oh.
Brian, these are extra cards. I don't know if you want those.
Okay, thanks. All right, so let's continue.
So we all need to know our MAC address? Is that what you should look at?
All you should compare MAC addresses. No, it doesn't have to match. All you're doing is when you get the envelope, you're going to look at which neighbor you pick, write down their MAC address, hand them the envelope. Pretty silly, but that's easy. Okay? They don't have to match or anything. It should be unique. MACs are designed to be globally unique. But anyways, so I'll come back to these slides so you can look and if you get confused, you can ask me your look. So basically, the first thing we're going to do is send a request. So I'm going to send a request for catgifts.com/catwrap.gif because I really want to see cats. So what? Pardon?
HTTP.
Yeah, I know. It's like I don't want to make this way more complicated. So nice jab. Okay. So the first thing we do is we take catgifts.com. Computers don't speak English, they don't know what it means, so they do DNS. So what they do is they're going to look up in the global DNS lookup thing, and there's some magic there. Catgifts.com goes to 3.1. So that is our magic IP where we need to route to. Okay, so that's the first thing that happens. So the next thing is the browser assembles HTTP request. So, and it kind of looks like this. So there's a verb, hey, get me this path, and it appends all these like headers and things and stuff like that. We won't get into what that means, but That's the data we need to send to the server. It's like, hey, this is what I want. This is kind of who I am, things I can take, and that stuff. So I've got that here. So what I would do when I pass it to the next layer, this is too big to send across the network. There's a lot of data here, there's a lot of characters, so it gets cut up. So I'm going to cut it up. This weird random thing.
I think this is the most props we've ever had in the talk, by the way. I think it's the only props we've ever had in the talk.
So, cool, I cut it up. So, there's a little problem here. If I send this out to the world, it could totally get mixed up, and there's no guarantee what happens on the other end once I cut it up. So there's this magic thing called TCP. So TCP, what it does, part of it is chops up that data, and it handles things if packets get lost and ordering and things like that. And what I'm going to do is, because this explains it a little better than I don't actually have it in, it's silly, but spoiler. Okay, you know what, I'm going to run out of time if I show this thing. Anyway, you can visit it later. All that happens is that little video explains what happens with TCP. And what it does is it takes all this chopped up data and it gives each one a number. So I'm just going to it gives an ordering. So the person assembling it can figure out, hey, this is the order you wanted. So I'm just going to put 1, 2, 3, 4 on it. Okay, I can mix them all up. It doesn't matter anymore. They're numbered. Okay, so that's the first thing it does. And then the next level is what's called IP. Okay, whatever. So I'm going to actually put, okay, let's go back to, so we're trying to get to 3.1. So I'm going to write 3.1, this is our packet. 3.1 is the header, okay? I'm going to put things in here, and then we're going to start the networking again. I'm going to send it here, okay? I'm going to get another packet ready while that's going, so this can totally be asynchronous.
I took a screenshot of the rules. Yeah. Right, maybe do you want to put the rules back up on the screen?
Oh yeah, yep. Good point.
Only pass.
Okay, I'm going to send a packet here.
Match your match. It matches. Somehow match your map on the card. So I write my MAC address on here?
Right, yeah, so write your MAC, or no, don't write your MAC. Look at your neighbor and write their MAC. Sorry. So look at their card, and then just look at the, right, okay.
We can, can we pass a pen with the envelope? And then
Yeah, we'll do that.
Oh yeah, sorry, pens. Sorry, those people who not, I have
just need it. Yeah, can go with the envelope.
Yeah, just send it with the envelope. You got one?
Okay, so I'm writing his MAC address on the envelope, right? Their MAC address. Okay. F1. Okay. So I have to make sure that's not my IP address.
Okay.
That way we have a little bit of class.
I can go, you go wide. Or I can go, yeah, you choose.
You're voting.
I wish I knew where the server was.
Well, it doesn't have to touch everyone, so sorry if you get missed out, but it's random here. I'm gonna send a packet to the back here.
Do you cross them out? No, you only cross them out. Yeah.
So when you get, if your packet comes to you, just check if you have the IP that matches. So if you're 3-1, you win, open the envelope, okay?
So you just strike it out if it matches.
That's cool.
We've done Windows.
I'm a computer, right? I'm thinking these things.
Oh, Can I do something while you do this? I'm just gonna. I figured out if we auto hide that bar, it'll go away.
Oh, okay.
Yeah.
So is there anything weird going on? Any problems yet? Oh, it's okay. Here. That's okay. Yes, question. Yes.
Cross network to I can test you 180.
Just have like a and I'm like, yeah, I thought it was the actual.
Yep.
One. I'll go that way.
You're deaf now.
Oh, there you go. All right. Okay. So 1C, and I'm definitely not 3.1. Yeah. Okay. All right. Okay. Everyone switch to pencil. There you go.
Here. Okay. It's coming back? All right.
Mine is.
Mine was
1,
2A. Okay.
Have to ever be always asked so many times.
There's no. This isn't like real networking. There's other things that would make it more efficient.
Let's see. Okay. I'll test you again. So this one is one. I don't know.
We have the most inefficient network.
I just gave it. I'm like, how can I?
I think so, yeah. Somewhere out here, 3.1 is like an island somewhere. They're in the bathroom right now.
Okay.
Hey, just ahead. We've got one packet to the destination.
I'm understanding why packets get lost now.
Oh, yeah. Mark just pointed out this is exactly why packets get lost. It's because it's like chaos out there.
Okay.
Yeah. It's already been that way.
1C, okay. Okay.
Pardon? He's opened it. He's got one packet. But what does it say? You just got a piece, right? Like, what number is it? So 2 came before 1, right? Yeah, well, I mean, we could do it by timestamp. That would be very big for the header. You want very small datas, right? So maybe just ordering one, like binary 1, 2, 3 is smaller. I don't know how TCP actually does it, but how many packets have you got? Is still one? Come on, packets, let's move. We need a network upgrade.
This is the slowest network request.
Yeah, that's right. You're like, sorry.
Yeah, now they're giggling dog gifts.
Yeah, that's right.
Doesn't he also need to acknowledge that?
Oh yeah, there's a lot of other stuff going on. I'm simplifying it a lot, so yeah. I asked him if he got the packet. He acted me. He's like, yeah, I got it. I'm still waiting. Okay, well that's going on. Maybe I'll move ahead just because you don't know the rules. We'll get there. So yeah, this was the original message. TCP chopped it up. There's other things that could happen, like if one of those packets dropped, I'd have to resend it out. And then the ordering is still happening. We're getting there. So basically, once all those packets kind of arrive, we'll pretend like. So the server over here has this cool cat gift that they want to send back, right? So what would the server have to do now? Like how is it going to send it back? The cat gets huge. So, sorry?
your IP address.
Right. Oh, I forgot. Yeah, true. I didn't write my IP address on there. So on the envelopes, I should have put the source IP. That should have gone with it. So I messed up there. So he would have that, and then he would just kind of go in reverse. He would use the scissors. You don't have to. Yeah, so he would chop it up in how many packets he wants. He'd bundle them up in envelopes. He'd order. You can cut it. Have all the packets arrive? We're there. Is that all of them? Yeah.
It started to make this.
Okay, so it's hard work making this work. Okay, I'll wrap up. I'll pretend they magically worked their way back. And I'd pull them out of the packets, I'd look at the ordering, I'd reassemble it, I'd go, oh my god, that's so cute! Okay. So, there we go, that was our object lesson. I hope that helped kind of... Oh yeah, so also, Sean would also add these response headers to the data. So it's all like, what's the content type of this thing? So I can figure out how to decode it, and what was the date, and it gives me tags so that if I ask for it again, I don't have to get all the data back, because I can say, did it change since last time? Cool things like that. So at the highest level, John sends that back, and I read it, and I don't have to ask for the cat thing again. Yeah. So again, this is just how this TCP/IP thing works. Sender, again, breaks into packets. All these routers were you people. Those routers are partly more like the dots, and then the little dots were like each individual ones. You're figuring out where to send it. There's probably a lot more efficiency that happens. Like there's routing tables that will be there, so it's like I know to send this way if it's like this stuff with these IPs. Yeah. So any questions on that? That was kind of crazy chaos, but any questions while I'm here? I'll pause for a second. If that's fine. And is TCP the only way? And the answer is no. So TCP is very slow, but it's reliable. There's a lot of chatter that happens. So this is where you get your email and web stuff happens. Usually you're talking from one person to one person. Or one server to one server. There's what's called UDP, which is a different protocol, which is just basically like you just keep sending packets and hopefully they get there. It's way faster. There's less overhead. This is where you get things like streaming music or VoIP and stuff like that. And there's different topologies you can do there. You can send to everyone at once, so like your packet gets copied and goes to everyone, or you could like kind of have cool multicast stuff. So so this I just wanted to kind of let me wrap up. Just give you an intro into networking. Just like that's kind of the high level of like what happens when you do a web request when you do in the browser. So if I actually So here was the cat TF5 seamlessly sold. And if I open up the console and go to network cat.
You can do plus on that,
Sorry?
you can do command plus to make it bigger. Or...
Right. So what's super handy, Chrome actually gives you cool info if you've never used it. If you're new to these things, you open up your console and you can see these actual requests. If you click there, you can see cool things like what were the request headers that were sent, what were the response, or what were the URLs and things like that. It helps you kind of debug sometimes when you have weird stuff going on with your web requests. This is kind of a handy tool. But so basically, this is what we saw kind of in that example. Anyways, let me go back. So I'm kind of on that topic of like, are there other ways? The internet's opening a lot of new frontiers for networking, which I think are super exciting. One cool technology is what's called WebRTC, and it's a lot less server, like client server. Like, hey, YouTube is hosted by one company, where if they go down, you'll never see all those videos again. They're pretty huge. They probably won't, but who knows? Weirder things have happened. But WebRTC is more about like peer-to-peer type topologies. Cool things it enables, something like WebTorrent.io. You can actually torrent data with just browsers. There's no server, and it's an actual live thing. I use it to watch movies and cool stuff. Hyperdrive is another cool one. It's more around like if you were doing scientific data, you can store those change sets. So like, hey, we've got new data coming in, and it lets everyone share that, replicate that data. Instant.io is a lot like, hey, I want to share this one thing with you, but I don't want to put it on a server. It gives you a cool little URL. Talkie.io, we use that at work all the time. It's like alternative to like Google Chat or Skype, but it uses WebRTC totally in the browser, and it's really cool. You got audio, video, that type of streaming data, and it doesn't actually hit a server anywhere. So that's pretty much it. It was just more intro into the anatomy of a web request. You can use cool inspectors and see all this stuff if you want to dig in there. And hopefully this leads into more talks just about like headers, URLs, and stuff like that. But I'll save that for next time. So thank you.
Thanks, Ryan. Does anyone have any questions for Ryan? It was pretty thorough.
Okay.
Good. Thanks, Ryan. All right. So we'll give Ryan a minute to take his laptop down, and we have up next is Abram. So I'll let Abram get set up too. All right.
Am I slides anymore?
I don't think so.
Okay.
Abram, do you want to present off yours?
Put your IP
And you can keep those cards if you want.
Can I stop?
You can unplug that, and that will keep going. I should stop the recording, I guess, but this should continue.